All right, I'm going to be working study guide number 2 or study guide B, depending on what you're looking at. You'll notice that there is a test identifier in the top right hand corner that says B, but also next to the study guide I wrote 2, just to try to clarify which one we're working on right now. And on this video, I am just going to work through problems numbers 1 through 13, and then I'll post another video where I will work 14 through 26. So you'll need to watch 2 separate videos if you want to see all of them. But this one, I'll just work all of them, numbers 1 through 13, and on the next video, I'll work 14 through 26. So I'm just going to start with number 1 and work through every single one of these. Now, number 1 simply asks which equation is an identity. So what I'm going to do is, they give me multiple equations, so I'm actually going to have to take the time to look at each equation individually and figure out which one of them is an identity. So I'm just going to start with equation A, which says 6m minus 3 is equal to 7m plus 4 minus m. Okay, remember this equal sign really divides my problem in half, and so what I'm going to do here is I'm going to combine like terms on this left side of the equation over here. Okay, you notice I have a 7m and a negative m, and since those are like terms, I can combine them. Now 7m minus m gives me 6m, and then that plus 4 I'm just going to bring right down, so plus 4, and on the other side our 6m minus 3 we're just leaving alone. And I can already tell that this one's not going to be an identity. Notice that the 6m's match, right? So our variables match, but this one has a negative 3 and this one has a positive 4, okay? And since we're looking for an identity, this one is not going to be it because both sides of the equal sign do not match. All right, so now I'm going to go down and look at B, okay? So equation B says this. It says 5w plus 4 minus w is equal to 6w minus 2 times w minus 2. So I'm going to cut this thing in half again, and there's some work to do on both sides of the equal sign this time. Notice over here I have a 5w and a negative w on the left. So if I combine like terms there, 5w's minus a w leaves me with 4w's, and my plus 4 I'm just going to bring down. On the other side, I need to use the distributive property. So I'm going to bring this 6w down and leave it alone, but I have to distribute that negative 2 right there. So the 6w just stays, and then I'm going to distribute this negative 2. Now negative 2 times w makes negative 2w. Then negative 2 times, and notice that is a negative 2. Pay attention to the sign in the front. So negative 2 times negative 2 makes positive 4. Now the left side of this equation is fine. I'm going to leave it alone. It is 4w plus 4. But I can still do some simplification on the right side because I have this 6w and this minus 2w. And so I can combine like terms there, which means that 4w plus 4 is what I really have on the right-hand side. That 6w minus 2w gives me 4. And it's at this point right here that you can see that this is an identity because what's on this side of the equal sign and what's on that side of the equal sign are exactly the same as one another. So the correct answer to number 1 would be B. That's the one that is the identity. And now that we've already found it, we actually don't even have to check C or D, right? Because we already know that number 1 is the correct answer. Or sorry, letter B is the correct answer to number 1. All right, so now let's look at number 2. Number 2 says negative 6 is equal to x divided by negative 2 plus 4. Now in this one it's just a 2-step equation, one of the easier ones we worked at the beginning of the year. And so what I'm going to begin by doing is trying to get x by itself, and so I need to move, the first thing I need to move here is the 4 because it's the thing farthest away from the x. And since they're adding 4, I'm going to subtract 4 from both sides. So I'm going to put my negative 6, but then I'm going to add in that negative 4 right there. So x minus 2 stays, the plus 4 stays. So I write everything down the way it is, but then I'm also going to include a minus 4. Okay, and here's my equal sign, and you can see that I put, negative 4 on both sides of the equal sign here. So on the left, I combine like terms. Negative 6 minus 4 is negative 10. And on the right-hand side, this x minus 2 stays, but my positive 4 and negative 4 cancel one another out. And so now I just have negative 10 is equal to x over negative 2. Still trying to get x by itself, and so what I'm going to look at is the fact that x is being divided by negative 2. So to counteract that, I'm going to multiply on both sides by negative 2. Since they're dividing, I'm multiplying, and I want to multiply by negative 2. So these negative 2's will cancel out, and that leaves me with just an x on the right-hand side of the equation. And on the left-hand side of the equation, make sure you know this is multiplication, right? I'm doing negative 2 times the negative 10. Don't confuse that for subtraction. So negative 2 times negative 10 is going to give me a positive 20. Okay, so the answer to number 2, x equals positive 20. All right, let's look at number 3. Number 3 says 11 is equal to negative d plus 15. And so I want to get d by itself in this problem. And you can see the thing that is with the d is this 15 over here. And now they're adding 15, so I'm going to do the opposite of that. So here's my equal sign. The 11 was already over here, but I'm going to add in negative 15. So that's new. Negative d plus 15 was already there. And then I'm going to include now this negative 15. So you can see I put this negative 15 on both sides of the equal sign. And so on the left-hand side, 11 minus 15 gives us a negative 4. Will be equal to negative d. And then the positive 15 and the negative 15 on the right-hand side of the equation cancel each other out. Now, when I get here, this is a little curious because there's nothing but a d on the right-hand side of the equation, but it's a negative d. Now remember, I don't want to know what negative d is equal to. I want to know what just regular d is equal to. So what I'm going to have to do is get rid of this negative sign. So the way you want to think about this is like there's a negative 1 being multiplied by the d. And so if there's a negative 1 times d here, what we're going to do is we're going to divide by negative 1 on both sides of the equation. Remember, if they're multiplying, we'll divide. And so if we divide by negative 1 on the left-hand side, negative 4 divided by negative 1 gives us positive 4. And on the right-hand side, my negative 1's will cancel one another out, so I have d, right? And so the answer is that d equals 4 for number 3. Let's go and look at equation number 4. Okay, so problem number 4 on this study guide says that 2 is equal to negative 9 plus z over negative 3. Now, if you remember, we've talked about a problem like this before, and the thing that's different about this one is the fact that it's not just the z being divided by negative 3, but it's the entire top, right? So you have to think about that top like it's in parentheses. And if that's the case, this negative 9 up top in parentheses with the z, they're attached to one another. So the first thing you would need to get rid of would be the thing on the outside, which in this case is actually the negative 3 that's on bottom. Okay, so remember, when the entire thing is being divided by negative 3, then we're going to have to actually get rid of that thing on bottom first. And in this case, the negative 3 being on bottom means that they're dividing by that negative 3. So what we're going to do is we're going to multiply by negative 3 on both sides of the equation. Okay, so now I'm going to multiply by negative 3 on both sides. Now on the left side of my equal sign, this gives me negative 6. And on the right side, the negative 3's will cancel one another out. And so all we have now is negative 9 plus z. And I can drop the parentheses because they're by themselves now. There's nothing else with them, so the parentheses can go away. Now remember, I'm still trying to get z alone. That's what I want to get by itself. So I got to get rid of this negative 9. So since the 9 is negative, in order for me to get rid of it, what I'm going to do is I'm going to add 9 to both sides. So over here, I've added in my negative 9 or my positive 9. So on the right side, I'm going to do 9, and I'm going to put my plus 9 right behind it so I can see that they are, the like terms that I'm going to combine. And on the left, negative 6 plus 9 makes 3, and on the right, negative 9 plus 9 will cancel, and so we just get z. So 3 is equal to z, or z is equal to 3. Right? You could write that either way. Okay, let's look at number 5. Number 5 says that 5 times y minus 3 is equal to 10. So on this problem, I need to get y by itself. And so there are actually a couple of different ways you can work this problem, but I'm actually going to go ahead and use the distributive property to work this one, okay? So when this 5 is outside of this, this 5 is outside the parentheses here, that tells me that I need to distribute this 5 is the first thing that I want to do. So I'm going to distribute the 5, and 5 times y makes 5y. And then 5 times this negative 3 will give me negative 15. And all of that stuff should be equal to 10. And now in my attempt to get y by itself, the first thing I need to get rid of is this negative 15. So since they're subtracting 15, I'm going to come back over here, and I'm going to add 15 to do the opposite of what they do. Use my inverse operation. And so that's great because on this left side now, the negative 15 and the positive 15 will cancel and just leave me with 5y. And on the right-hand side, I can combine like terms. 10 plus 15 is 25. And now to get y by itself, I'm simply going to divide by 5 on both sides of the equal sign. So now on the left, they cancel, and y is equal to, on the right-hand side, 25 divided by 5 makes 5. So y is equal to 5 is the answer to number 5. All right, number 6. This is probably one of the hardest problems on the study guide. Number 6. It's a nice long equation. It says that 3p plus 11 is equal to 5 times p minus 1 minus 2 times 7 minus 2p. And my equal sign is what's kind of cutting this problem in half. We got two separate sides that need to be the same as one another. And so I'm going to leave this left side alone because there's not a whole lot going on over here. But if you look on, okay, so the left side I'm just going to leave alone. But if you look on the right-hand side of this line on the equal sign, you notice that there are two different places where we need to use the distributive property. This 5, well, that parentheses needs to be distributed. And then this negative 2 needs to be distributed to this parentheses right here. So I'm going to do a couple of those at the same time, and I'll color code this one to help. So let me start with the 5, right? I'm going to start by distributing this 5 to this first parentheses right here. So 5 times p makes 5p. And 5 times the negative 1 gives me negative 5. Now for this second set here, remember this is a negative 2, right? That minus sign right there is really important. That makes this a negative 2. So I'm going to distribute a negative 2 to the inside of this parentheses. So a negative 2 times 7 makes negative 14. And a negative 2 times negative 2p, well, a negative times a negative is going to make a positive, and 2 times 2 is 4. The p just comes along for the ride. And so now that I've done my distribution, I need to come over to the right side of this equation and just see if I can kind of clean things up. So once again, the left side, I don't need to do anything to it yet, right? It's still nice and neat over there. But on this right side, I want to look and see if I can combine like terms. And I see already that there's a 5p and a 4p. So I'm going to go ahead and put those together. So 5p and 4p combine to give me a 9p on this side of the equation. And then you'll notice that there's a negative 5 and a negative 14 that are like terms as well. And so if I put those together, negative 5 and negative 14 makes negative 19. And now I have a normal equation that you've probably seen before where I have variables on both sides of the equal sign. And so the first thing that I want to do is try to get my variables together. Now it doesn't matter which one of these you try to move first. You can move the 9p or the 3p first. That doesn't really make a difference. You just have to pick one, okay? So you can pick whichever one you want to, but in order to work this problem, I'm actually going to pick the 9. So I'm going to move the 9p. So I'm looking at this 9p right here, and I want to know how I can get it to the other side of the equal sign. Well, since it is a positive 9p, the way that I can get it to the other side of the equal sign would be to subtract 9p. It is positive, so if I want to move it, I need to subtract 9p from both sides of the equal sign. So plus 11, and now I'm going to do minus 9p on that side. Then I'm going to come over here, and I'm going to do minus 9p on this side. So my 9p stayed, but I added this new negative 9p in, and then my negative 19 just stayed. Okay? So on the left-hand side, I can combine the 3p and the negative 9p, and those will make negative 6p, and the plus 11 will just stay. On the right-hand side of the equation, the 9p and the negative 9p cancel, and so I only have negative 19. And now this is a two-step equation, just like any other equation that we have ever done before. Just a regular old two-step equation. Okay, so I'm still trying to get p by itself, which means that I first need to move this plus 11 right here. So plus 11, so negative 6p plus 11. And if I want to move this positive 11, what I need to do is subtract 11 from both sides of the equal sign. And I'm going to move this over so I can keep up with it better. Negative 6p plus 11 minus 11 is equal to negative 19. And now we're going to subtract 11 from both sides. So I subtracted 11 from each side of the equal sign. You can go down here. All right, so now on the left-hand side, the positive 11 and the negative 11 cancel, and I just have negative 6p. On the right-hand side, negative 19 minus 11. So negative 19 would mean I would go down to the left on my number line. And then minus 11 would mean I'd go 11 more down the number line. And so by the time I was done, I would end up all the way at negative 30. So negative 6p is equal to negative 30. And now I need to get p by itself. And since they're multiplying by a negative 6, I'm just going to divide by a negative 6 on both sides of the equal sign. So on the left, my negative 6's cancel, and I just get p is equal to. And on the right, I have a negative 30 divided by a negative 6. So a negative divided by a negative is going to make a positive, and 30 divided by 6 is 5. So p is equal to 5. Okay, so let's go to number 7. It says that 5x plus 3 is equal to 6x minus 2. And so this one just starts off, as a equation with variables on both sides of the equal sign. And in order to work this time, I'm going to do it in the opposite order I did last time. Last time I moved my variable that was on the right-hand side of the equation. So this time I'm going to move the variable that's on the left-hand side of the equation. And so this is a positive 5x that I want to move so that it can join up with that 6x. So if I'm going to move that 5x, then what I actually need to do is subtract it, right? It's positive, so we have a positive 5x, so I'm going to subtract 5x from both sides of the equal sign. So this negative 5x is new, and on the other side I have 6x, and I'm going to put my minus 5x right behind it, okay? I'm going to put it right behind it. And so on the left, the positive 5x and the negative 5x cancel. We only have our 3. On the right, we have 6x's minus 5x's. So if I have 6 of something and then somebody takes 5 of them away, I'm just left with 1. But remember, since it's a 1, we don't have to write it in front of the number anymore. Okay, and so now we just have that 3 is equal to some number x minus 2. And you can probably solve this one in your head right now, but we'll continue to do the algebra, right? What number minus 2 will give us 3? Well, I'm going to add 2 to both sides to get rid of this negative 2 over here. So I'm going to say 3 plus 2 is equal to x minus 2 plus 2. So I added 2 to both sides of the equation in order to solve for my variable. And now 3 plus 2 is 5. And on the right, negative 2 and positive 2 cancel. And so x is equal to 5. Okay, let's go to number 8. Number 8 says 8d minus d minus 5d plus 5 is equal to 6d. Okay, so my equal sign, remember, is what's cutting this thing in half. And I want to, if you look at the left, there are a lot of like terms to combine here. So I'm just going to do them one at a time, though, right? I'm going to start by taking this 8d minus d, right? And I'm going to combine them. And if you do 8d and you take away 1d, then you're left with 7d. And then everything else, I'm going to copy down exactly the way it is. And now this time, what I'm going to do is I'm still trying to combine like terms, and I have a 7d and a minus 5d. So I'm going to take those two things and I'm going to combine them. So 7d minus 5d's will give me 2d's plus 5 is equal to 6d. Now, I want to get my variables together on one side of the equal sign. And if you look, this 6d on the right-hand side is already by itself. So that's nice and convenient. So what I'm going to do is I'm going to move the 2d to go over and join it where it's already by itself. So since this is a positive 2d, the way I'm going to move it is I'm going to subtract 2d's from both sides. So 6d minus 2d. And on the left, they cancel, and so 5 is equal to, and on the right, 6d minus 2d is 4d. Now I'm going to divide by 4 on both sides of the equation. And my 4's on the right cancel, and I get this fraction, 5 over 4 is equal to d, which is fine. And I'm just going to leave it that way. I'm just going to let it say 5 over 4 is equal to d. You don't have to try to change that fraction into a variable, you don't, or into a decimal or anything like that. If you get a fraction that doesn't divide evenly, you can just leave it exactly the way it is, and there's nothing wrong with that whatsoever. Okay? So let's look at number 9 now. So number 9 actually gets us into some of the word problems, right? Some of the word problems. So we'll actually read through these and talk about them, okay? We're going to set up an equation and solve on each of these. So looking at number 9, it says, you're driving to visit a friend in another state who lives 500 miles away. You're driving 50 miles per hour and have already driven 250 miles. Write and solve an equation to find how much longer in hours you must drive to reach your destination, okay? Now remember, whenever you have a word problem, you always are trying to get to, some total. There's, two things end up needing to be equal to one another. And in reading this problem right here, the first statement is really, really important. It says, you're driving to visit a friend in another state who lives 500 miles away. And so what that means is all of your driving, right? This is how much driving you're going to have to do, right? Whatever amount of driving that you do on this side of the equation, if you're going to your friend's house that's 500 miles away, then what you want is you're driving whatever you do to end up taking you 500 miles to your friend's house. So at the end of the day, whatever you've done on this trip as far as your driving goes, you want it to come and you want it to end up equaling 500. So let's talk about what sort of driving you're doing, okay? Well, if you notice, the first thing it says that you are driving 50 miles per hour, okay? So that's one thing. We're going to go 50 miles every hour. So what I'm going to do is I'm going to put an H there for hours. For every hour that I've gone, I get to travel 50 miles. And then you notice that it says you've already driven 250 miles. So if we're talking about what's happening here, you've already covered 250 miles. So I'm going to add that 250 in there. And the easier way to think about this would probably be if I wrote these in the other order. If I wrote, I've already gone 250 miles, plus I'm still going 50 miles for every hour that I travel. And so writing it that way may be easier for you to understand what's happening, right? You've already done 250, plus you're still going 50 miles every hour, and you want to end up going a total of 500 miles. And so now you have an equation that you can solve, right? We wanted to find the number of hours that it would take to get there. So we're trying to get h by itself so that we can have the number of hours that it would take for us to get there. So in order to get this 50h by itself, the first thing I have to get rid of is this 250. And if you notice, it's positive, so I'm going to subtract it from both sides. I'm going to take that 250 and I'm going to subtract 250. Keeping my equal sign in the middle here. So 500 minus 250. And on the left, the 250 and the negative 250 cancel. So we just have 50h is equal to. And on the right, 500 minus 250 gives us 250. So 500 minus 250 is 250. And now we want to get h by itself. And so we're going to divide by 50 on both sides because they were multiplying 50 times h. So I'm doing the opposite here by dividing 50. And the 50s on the left cancel, and we get that h is equal to, and now 250 divided by 50, okay, the zeros will cancel one another out. And you can really just go ahead and think of this in your head like 25 divided by 5, which is 5. And if you remember, h stands for hours. So what this is telling us is that it's going to be 5 more hours before you get to your friend's house if you keep driving at the exact same speed. All right, let's look at number 10. It says, a customer went to a garden shop and bought some potting soil for $16 and 5 shrubs. The total bill was $69.75. Write and solve an equation to find the price of each shrub. Okay, so here's what happened. They went to the store and they bought some stuff. So I'm going to put bought. And what ended up happening was they had to pay a total, right? They had to pay a total price after they bought some things. And so, whenever you go to the store, whatever you buy, all of the stuff that you buy put together gives you your total price, okay? And so we just need to consider these things. When she was finished, when everything was said and done and she was paying her bill, she was paying $69.75. Now, what did she buy? If you go and look, it says, a customer went to a garden shop and bought some potting soil for $16. So we know exactly how much the potting soil was. She spent $16 on potting soil. And that's an addition word, right? And so besides that $16 she spent on potting soil, she also bought 5 shrubs. Now, it doesn't tell us how much the 5 shrubs cost, and that's actually what we're looking for. So however much a shrub cost, right, S, however much a shrub cost, she had to pay that price 5 times. And that's why we're multiplying these things together, right? 5 times S would be 5 times the price of a shrub. Okay? So now I have my equation set up and I just want to solve it. Okay? I'm just going to solve this equation and I'm trying to find the price of a shrub. So I'm trying to get that S right there by itself. And so hopefully you can see that the first thing I'm going to need to move is the 16. And since this 16 is positive, I'm going to subtract it from both sides. So plus 5s is equal to, now I got my equal sign a little bit out of line here, but that's okay. As long as I keep everything on the right side of the equal sign, we'll be okay. So 16 minus 16 plus 5s is equal to 69.75, and then I got to subtract that 16 from both sides of the equal sign. You can see I added in the minus 16 on both sides. And on the left, they're going to cancel. We just get 5s. But on the right-hand side, we get 69.75 minus 16. And so what that's going to leave us with is 53.75. 63.75. Okay, and this is, some of this arithmetic is getting a little more difficult. So you may need to use your calculator, okay? And so if you want to take out your calculator and do 69.75, and I'm going to do mine just to make sure I didn't make a mistake. So 69.75 minus 16, and you do get 53.75. And now our next step in trying to get s by itself is to divide by 5 on both sides of the equal sign. So this means that s is equal to, and now I'm going to take that 53.75 in my calculator, and I'm going to divide it by 5, and it tells me 10.75 is the correct answer. Okay, so the shrubs cost $10.75. And the reason why I'm saying it that way is if you look at the problem, it says write and solve an equation to find the price of each shrub. So this is a price for the shrub, and we measure prices in dollars, right? And so the price of that shrub would be $10.75. Okay, let's look at number 11. Number 11, it says, Steve wants to buy a $490 bicycle. Steve has no money saved, but will be able to deposit $40 into a savings account when he receives his paycheck each Friday. However, before Steve can buy the bike, he must give his sister $70 that he owes her. For how many weeks will Steve need to deposit money into a savings account before he can pay back his sister and buy the bike? Okay? And so now we're looking at Steve. You may want to, pause the video for a second and read again by yourself this question to make sure you understand what's going on. But here's the idea. Steve, he's got money. So I'm going to call this cash flow. Right? And I'm going to call the other side bike, because here's what's happening. Steve has what's called cash flow. He has money coming in, okay? But in this problem, hopefully you also notice that he has some money going out. So he has money that's moving around, and he wants to get to the price of the bike. And you notice that the price of the bike is $490. And I'm going to put that on one side of the equal sign by itself, because what we're trying to do here is we want his cash flow to end up giving him a total of $490. So, what does his cash flow look like? Well, it says that he is able to deposit. Now, that's a key word. What it means to deposit money means that you actually put money into the bank. So, you're saving money, you're keeping money whenever you put it into the bank. So, when it says that he can deposit $40 into his savings account when he receives his paycheck each Friday, that means that every week he's actually gaining $40, okay? So this is what it means for his cash flow. He gets $40 every week, okay? And he's up $40 every week. So it's a positive 40 because he's putting money in. Now, the next part says, however, before he can buy the bike, he must give his sister $70. Now, as far as his cash flow goes, that $70 doesn't happen again and again and again. He just needs to give his sister that $70 one time. But that is cash flow that's going out. So his cash flow gains $40 every week, but he has to lose that $70 that he owes his sister. Okay? And that's all the information that the problem gives us. So here's his cash flow, $40 coming in every week, but he's got to spend $70, and he wants to get up to a total of $490. And it wants to know how many weeks. Well, that's good because we have W right there for weeks. That's our variable to tell us how long it will be before he can save up that money. And now to get W by itself, I got to move this 70. So there it is right here. That 70 is what I'm trying to move. And since it's negative, I'm going to add 70. So I'm going to add 70 to both sides of the equation, and these two things will cancel. So 40W is equal to, and then 490 plus 70 is equal to 560. And once again, we're dealing with some big numbers, so you may want your calculator. And I'm going to use mine here really quick just to check myself. 490 plus 70 is 560. And now I want to get my W by itself. So since they're multiplying 40 by W, I'm going to come and I'm going to divide by 40 on both sides of the equal sign. And 40 divided by 40 is going to give me a 1 on the left, right? So there's nothing but the W left over there. They cancel. And then on the right-hand side, I have 560 divided by 40, which is 14 when I use my calculator. So 560 divided by 40 is 14. So that means it's going to take 14 weeks in order for Steve to be able to buy the bicycle that he wants. Okay, so 14 weeks before Steve can buy the bike. All right, let's move on to number 12. And number 12, I'm actually going to pick up at B, okay? So part B, part A and B, they didn't really do anything. There's not really a lot for you to be able to write down. So I'm just going to go ahead and copy down what they have here. And then for C, they have 23 plus 11. I'm just going to copy this on the smart board so you can see, and I'll be able to point out a few things to you. And then D is 23. Okay, and this is what they have, and it's our job to tell which property justifies each step. And I'm starting at B because they didn't really use a property to get from A to B. So I'm going to start with B. And remember, the start is nice and easy. It's always just given, right? That was given to us. Okay? And then if you move from B to C, you really want to look for what's different. And so if you notice the difference from B to C is this right here. Those plus 11s, okay? What actually happened from B to C is that those plus 11s came in. But if you notice, here's the equal sign, right? So they put an 11 on each side of the equal sign so that the equation would stay balanced. And so if you remember, when we talk about adding the same number on both sides of the equal sign, that's called the addition property of equality, right? The addition property of equality. It just means that if you add the same number on both sides of the equal sign, then your equation stays balanced. The two things are still equal to one another. Then if you go and look at part D, okay, so now we're looking from C to D. What changed? What changed? Well, the only thing that changed, this side is exactly the same. This negative 11 is in the same spot. But if you notice, what happened is that 11 and that negative 4x traded places, right? They traded places. Now, two things that were being added together, negative 4x plus 11, switched to 11 plus negative 4x. And if you notice, they just traded places, and this is an addition problem, right? There was an addition sign in between them both times. And so when two things switch places like that, if you remember, when two things, there's addition going on, and the two things just trade places, that is the commutative property. And in this case, they're adding, so it's the commutative property of addition. And now we're looking for what changed from D to E. Okay, so we're trying to see what changed each time. And if you notice from D to E, what looks different is this negative 11 plus 11 went away. They kind of canceled it out, right? And that 23 plus 11, they went ahead and combined. And 23 plus 11 is 34, okay? And so all they did was kind of work things down. They just simplified. So we're going to say that they simplified. You just simplify to get there. And now if we look from E to F, what's different whenever we're moving from E to F? Well, this 34 and negative 4 are still there, 34 and negative 4, but they have this negative 4 on both sides that they're dividing by. So obviously the next step in solving this equation is to divide by negative 4 on both sides, so they added that in. But since they did it on both sides, and if you divide by the same number on both sides of the equal sign, it keeps the equation balanced. That's called the division property of equality. Okay, the division property of equality. So all that means is that if you divide by the same number on both sides of the equal sign, then the equation stays balanced, and so it's equal still. So it's the division property of equality. And now all they did is, to get to the next step, they actually just worked this problem out, right? The 34 divided by negative 4 does give you negative 8.5. And on the right-hand side, they canceled the 4s. So once again, they just did some simplification. So I'm going to say, to get from F to G, you just simplify. Okay, so let's go on to number 13. And this will be the last problem that I'm going to work on this video. You'll have to go and get the other video that'll be out there for you to be able to watch how I do the rest of the problem. So 14 through 26 will be on a separate video. Okay, look at number 13. It says find the value of y, and then it gives us this equation. So it wants us to figure out what y is if this equation is true. And this is just a simple equation, right? So find the value of y. Those instructions are a little bit different, but it's still the exact same type of problem. We're going to be doing the same things. We have an equal sign right there. So what I'm going to do is I'm going to try to simplify the left-hand side of this equation. And the reason I'm going to simplify it first is because hopefully you can see we have a 6y and a 4y over there. And so those are like terms that I can combine together. So a negative 6 plus 4, right? Negative 6y plus 4y. So if I combine those, it gives me negative 2y plus 14 is equal to negative 28. And now in order to get y by itself, they're adding 14, so I'm going to come back and subtract 14 from both sides of the equation. And on the left-hand side, the positive 14 and the negative 14 will cancel one another out, and we just have the negative 2y now. And on the right-hand side, we're looking at negative 28 minus 14. So negative 28 means I move to the left. Minus 14 means I move to the left even more on my number line, and so I would end up all the way down at negative 42. And now my next step in getting y by itself would be to divide by negative 2 on both sides. Remember, they were multiplying negative 2 times y, so I'm going to do the opposite and divide by that negative 2. And what that means is on the left, everything cancels, and all I have on the left-hand side now is my y. And on the right-hand side, negative 42 divided by negative 2, well, a negative divided by a negative makes positive, and 4 divided by 2 is 2, and 2 divided by 2 is 1, so negative 42 divided by negative 2 makes 21, and so y's value is 21. Okay, hope this video helps you. Hope you're studying hard, getting ready for the test on Friday. Good luck, and the next problems will be on the next video. 14 through 26 are on the second video.